Yeah, let's talk about how do we add, subtract, and multiply, actually, to matrices. It's probably maybe what you'd expect, but maybe not on multiply, but adding and subtracting is just about yeah. The first note on adding matrices is to add matrices, they have to be equal in size. In other words, they have to have the same dimensions. row and columns. Same row, same number of rows, same number of columns. For example, if I have A is 7, 2, 3, negative 1, 5, negative 4. B is 8, 2, negative 5, 6, negative 2, negative 3. And then C is 4, 1, 6, 8, and 7, negative 1. Those are the rows of C. Hopefully, obviously there, B and C have the same dimensions, don't they? This is and remember it's row times your columns is how it's usually listed. So the dimension of this, we have 2 rows, 3 columns. So this is a 2 by 3. 2 rows, 3 columns. So this is a 2 by 3. But this one is what?
3 by 2.
3 rows, 2 columns. So when we're adding and subtracting, as far as that goes, we can only add A and B. We can't add and subtract. We can't add or subtract C to these others, A or B there. So we can add the A and the B, but we can't add the C. So that is one first note there. All right, so how do we do that? Well, like I said, it's fairly straightforward as far as adding goes. Multiplying is a little bit trickier, but to add them, you just add the corresponding entry. So to add A plus B, we do 7 plus 8. That would be 15. The 2 plus the 2, it would go in the next one, so that'd be 4. 3 plus the negative 5, negative 2. And then we do the same thing on the second row. Negative 1 plus the 6, give me 5. 5 plus the negative 2 is 3. And then negative 4 plus the negative 3 gives me negative 7. So you wind up with, clean it up, 15, 4, negative 2, 5, 3, and negative 7. Would be A plus B. So just add entry by entry. What about subtraction? Same thing, except you're going to subtract the A entry minus the B entry, so that would be 7 minus 8, negative 1 would be the first one. Then we'd have 2 minus 2, so that'd be 0 for the second one. Then 3 minus negative 5, that would be 8, yeah. And then negative 1 minus 6 is negative 7. 5 minus negative 2 should be 7. And then negative 4 minus negative 3, negative 1. So it's negative 1, 0, 8, negative 7, 7, negative 1. And you don't have to write all that stuff. I'm just writing it out so you can see what we got there. Okay? So adding, subtracting is fairly nice. Now, one other thing we can do that's fairly nice is multiply just oops, I should have kept mine. I'm going to use the same same 2 here, I didn't mean to erase them. So it's 7, 2, 3, negative 1, 5, negative 4. And B is 8, 2, negative 5, 6, negative 2, negative 3. One other thing we do is, it's called a scalar multiplication, but we can multiply a matrix by just a number. In this case, 4 times A, and it's just what you would think. You're just multiplying each entry by that number, by 4. So 4A would be 28, 8, and 12, negative 4, 20, and negative 16. Okay, it's called a scalar multiplication, because we're just multiplying by just a number. All right, now, the one thing, not too complicated, but what do you think we do there? 4A minus 5B. Well, we've got the 4A, 28, 8, 12, negative 4, 20, and negative 16. But we're going to subtract from that 5B, so what would 5B be? Well, it's just 5 times that one, right? 40, 10, negative 20, 30, negative 10, negative 15. So I'm just multiplying each entry on the B one by 5, and then I'm going to subtract those two, which we just talked about. To subtract, you just subtract entry by entry. So what have we got? 28 minus 40 is negative 12. 8 minus 10 is negative 2. 12 minus negative 20 is 32. Negative 4 minus 30 is negative 34. 20 minus a negative 10. Be sure to keep up with the signs though. Positive 30, do that one. And then negative 16 minus a negative 15, get negative 1. Do that right? Believe that? Except, I missed something. I missed this one. What should this one be? Negative 25, yeah. I was just checking. Called me on that. Yeah. This should be a negative 25 because you got 5 times negative 5. I don't know where I got negative 20 out of that. So that would make this one what? 12 minus negative 25 should be 37. Now we good? Look okay? Question or concern? So those are very nice, fairly straightforward. The multiplication, when you multiply 2 matrices, it gets a little more complicated. So let's talk about that. Multiple matrices. Now, whereas adding matrices, they have to have exactly the same dimension. That's not the case in multiplying matrices. They may not have the same. There has to be one thing that has to be matching, and it's not. They don't have to be equal. I mean, you can multiply same size. They're square anyway. Anyway, here's what it is. If A is m by n, so you got m rows and n columns, and B is n by p, so n rows and p columns, then A times B is, so that this is a scenario when you can multiply. So notice they may not be matching as far as rows and columns are, because M and N could be different, N and P, those are different. But what is matching here? Well, yeah, the N's here are the same. But notice one's the columns, the other's the rows. So the columns of the first have to match the rows of the second. That's what this says. So what you wind up with is an M by P matrix. And I'll show you how that works. But that's the first thing to note here. The rows of the first, the columns of the first matches the rows of the second. And you'll see why they multiply. To multiply. If that's not if that is not the case, you can't multiply. If the rows of the first, the columns of the first don't match the rows of the second, you can't multiply. You'll see why here in a second. Okay, so it's not that they're the same size, it's just the columns here match the rows here. The others may not match. All right, so let me just show you here with an example or two. So let's say A is 1, 2, 3, 4, 5, 6. And then B is 7, 8, row 1, and then row 2 is 9, 10. So I've got here, this is 3 rows, 2 columns. And this is 2 rows, 2 columns. So we've got the proper dimensions matching. Columns here match the rows here for multiplication. So let's talk about what A times B is. Well, what it amounts to is I'm going to take the rows, so I start with A, so I take each row of A and multiply it by both columns, in this case, the columns of the B. So that's why the columns and the rows have to match. So I take each row here and multiply it by the column over here. So here's what that means. So I'm going to take row 1, the entries there, and multiply it by the column entries over here. So it's 1 times 7 plus 2 times 9. See what I did there? First row times the first column. 1 times 7, and then 2 times 9. That's the way it works. The way multiply works. All right, now I do the same thing with column 2. So I take the 1, 2 row and multiply it by the 8, 10 column. So that'd be 1 times 8 plus 2 times 10. And that'd be the second entry in that. And we'll multiply it all out here in a second. All right? But now we're going to go do the same thing for row 2. So that was row 1 with the columns of B. So now we move on to row 2 of A. So we take row 2 of A, multiply it by both columns of B. So it'd be what? 3 times 7 plus 4 times 8 would be the first one. And then the 3, 4 row times the other column of B. So it'd be 3 times 8 plus 4 times 10.
Okay, hold on. On the top one, we did 1 times 7 and then 2 times 9.
Oh, did I mess it up?
Yeah, I think so. It doesn't seem like it's a pattern to me.
Oh, okay. That's enough.
Is that better?
Yeah.
Okay.
Thank you. Just checking.
Yeah.
All right. So that was row 2 of A plus multiplied by the columns of B. So we've got another row of A, so we've got to do that very same thing with the third row of A. So take the third row of A times each column of B. So it's 5 times 7, 6 times 9. And then 5 times 8 plus 6 times 10. And so that'll give us what? 7 plus 18, so that's 25. 8 plus 20, so that's 28. 21 plus 36. 57. 24 plus 40, 64. 35 plus 54, 89. And then 40 plus 60 is 100. Do the calculations there. Okay? And so, yeah, we wound up with 3 rows, 2 columns, which is exactly what we said originally. What you wind up with is a 3 by 2 when you multiply it. Okay? All right. Now note this. If I have A is 7, negative 5, negative 3, 1, and B is 6, negative 4, 2, negative 5. What's A times B there? Because this is a 2 by 2 and a 2 by 2. Those are obviously going to be able to multiply. All right, so A times B. So I take this. I would take first row of A times both columns of B. And that'll give me my first two entries here. So it'd be 7 times the 6 plus the negative 5 times the 2. Then I do the same thing with row 1 here, but times the second column of B. So it'd be 7 times negative 4 plus then negative 5 times negative 5. And then do it all over again because I got a second row of A. Take the second row of A times both columns over here. So it'll be negative 3 times 6 plus 1 times 2, and then negative 3 times negative 4 plus 1 times negative 5. 42 minus 10 is 32, negative 28 plus 25 is negative 3. Negative 18 plus 2 is negative 16, 12 minus 5, 7. Is that right? Checking on that. What I was going to show you was, you think that would be the same thing? So that's A times B. What about B times A?
Well, you're swapping it.
Swapping them out, aren't I? So B times A, I would take 6, negative 4, 2, negative 5 times the 7, negative 5, negative 3, and 1. So, for one thing, that's definitely not starting off the same, because you got the first row here times the 2 columns over here, right? So you have 6 times 7 plus the negative 4 times negative 3. Do the first entry there. And then I take the row times the other column, so it'd be 6 times negative 5 plus negative 4 times 1. Yeah, those aren't going to give me the same entries, are they? And then do the same thing for row 2. 2 negative 5 times the 2 columns over here, so that'd be 2 times 7 plus -5 times -3. And then 2 times -5 plus -5 times 1. So I get 42 plus 12, 57. -30 minus 4 is -34. 14 plus 15 is 29. And then -10 minus 5 is -15. Does that sound right? Do those right? Can't add. 42 plus 12 is 52, not 57. Think right now. So the point is here, the order matters on multiplying. A times B does not equal B times A in general, in matrices. So that's the commutative property. It is not commutative. Multiplication is not commutative. Addition would be commutative out of the three we talked about, but multiplication isn't commutative. Any questions on that? The only, like I said, the other thing I would mention is, again, that's why, so if I tried, what was my first two back here? Go back to these first two. So this is a 3 by 2, and this is a 2 by 2. So could I even do B times A? We did A times B on those, but could we do B times A? Well, this is a 2 by 2, and this is a 3 by 2. Do the proper dimensions. Yeah. For multiplication to work, these two have to be the same, don't they? The columns here have to match the rows here. So if those two things don't match, you can't do the multiplying. I mentioned that, but yeah, you cannot multiply these in this order. We could do the A times B, but not the B times A. Just can't, just won't match up. All right, well,